Okay, let's learn what is limiting reagent in a chemical reaction. So we know that in a chemical reaction, what reacts and that is kept on the left hand side of a chemical reaction. Chemical equation is known as reactant, and what's formed known as product. Right. So here, in the example that we have taken earlier, this is methane burning in presence of oxygen, giving the products carbon dioxide and water. So we know that it means 1 mole of methane is reacting with 2 moles of oxygen to form 1 mole of carbon dioxide and 2 moles of water. In this section, how much mole of carbon dioxide will, if you take 1 mole of methane and exactly 2 moles of oxygen, then it will form 1 mole of carbon dioxide, right? But if instead of taking 2 moles of oxygen, if we take only 1 mole of oxygen, what will happen? This is 1 mole of methane, but only 1 mole of oxygen. So how much carbon dioxide will be formed? It depends on how much oxygen is there. Since only instead of we require for 1 mole of methane we require 2 moles of oxygen, but we are using only we're supplying only 1 mole of oxygen. Means the amount of product formed will depend on the quantity of the oxygen that is present. And since it is only half, it will be only half of the carbon dioxide will form. So that if we add a little more, more product will form. So the amount of product formed depends on the quantity is being limited by the amount of this particular reactant. So this is known as limiting reagent because this particular reactant is limiting the quantity of the product form. Its presence is limiting the quantity of the product form. So they are known as limiting reagent. It can be this also, depending on the kind of reaction and how much mole it requires. Right? So what is limiting reagent? Limiting reagent is a particular reactant which decides the quantity of the product that will be formed. Right? Now, what happens is when we carry out chemical reactions in laboratory, how much reactant we are going to use, what will be the limit, which one will act as the limiting reagent. It all depends on, because we are using we do in a solution. Most of them are solid, and we put them in water or in any other liquid and make solution. So we need to understand, in order to find the concentration of those solution, where there are many methods by which we can measure the concentration of solution or how much reactant is there. The reactions are carried out in solution by using solutions. Solutions means most of the time you use water as a solvent. So we need to know how much reactant or solute is present, right? And so in other words, we need to know what is the concentration of the solute, or what is the concentration of the solution, which means that, in other words, how much reactant is there, how much product is formed. So we need to understand how the various kinds of how the concentration of a solution can be expressed. According to the textbook, we can express it in four different ways. It's called mass percent, mole fraction, molarity, and molality. What is mass percent? It is defined as number of moles of the solid. Number of mass. The mass of the solid, percentage of the mass of solid in percentage of the mass of the solid with respect to the mass of the solution. So how will you calculate? We keep the mass of solid above, and below that the mass of the whole solution multiplied by 100%. So it is a mass percentage of the solution compared to the solution of the solute, mass percentage of the solute compared to the mass of the solution. What we need to point out is that so mass of the solid is compared to the mass of the solution. Just remember this one, mass of the solution. And what is solid? Solid means the substance that is present in a less amount in a solution. Suppose water, in the water, if you're adding salt and making a solution, then the salt is a solid. in the whole water is a solvent, and a combination of it is solution. The solid plus solvent turns out to be gives the solution. So what is mass percent? It is the percentage of the solid in terms of percentage of the mass of the solid in terms of mass of the solution. And what is a mole fraction? Mole fraction is, suppose in a solution there are two components, a component A and component B. That will be two compounds A and B. What is mole fraction of a particular component of a solution is nothing but the ratio of the number of moles of that substance to the total number of moles present, total number of the quantities that are present. Similarly, mole fraction of quantity of component B of the solution will be Nb divided by Na plus Nb. Na plus Nb means number of moles of the solid of the component A plus number of moles of component B. But one thing that you can observe over here is that mole fraction of A plus mole fraction of B, if you add these two things, you'll get 1. Xa plus Xb will be 1. And what is molarity? It is the most common way of expressing the concentration of the solution. It is denoted by capital M. This is the number of moles of a substance of the solid in 1 liter of solution. Number of moles of the solid in 1 liter of solution. So how will you find molarity? You keep the number of moles of a particular substance A, suppose solid, above, and below that you divide it by volume of the solution, not the solvent, volume of the solution, and that too in liter. And it is temperature dependent, because we know that volume of a substance, it changes with temperature. So it is dependent on temperature. It may increase or decrease with temperature, that we'll discuss later on, but it depends on temperature. And what is molality? Molality is denoted by small m, and it is the number of moles of the solid in 1 kg of solvent. It will express in kg, per kg of solvent. And say what is special about molality? Every time we are expressing the number of the mass percentage, whether it is mass percentage or mole fraction or molarity, we're taking the solution mass of the solution or volume of the solution, right? But here we're taking mass of the solvent. So molality is a way of expressing concentration of a solid in terms of number of moles of solid which is present in 1 kg of the solvent, not of the solution. And since the mass does not depend on temperature, molality does not depend on temperature. So what is the difference between molarity and molality? One difference between molarity and molality is that molarity is dependent on temperature and molality is not.